Hello, everyone. Today we're going to talk about conjugation, and we'll talk about conjugation in terms of chemistry, right? So what does the term conjugation actually means in English language? Conjugation means to be connected to each other. Conjugation means to be in line with each other, or in line meaning in connection with each other. So that's the English word conjugation mean, right? But in chemistry terminology, we used conjugation to explain whether the p orbitals are in conjugation or not. Okay, and so before we get into all of these molecules, to understand whether these molecules are in conjugation or not, we'll try to understand first off what a double bond is, right? I know I have talked about this before. A double bond is nothing but overlap of p orbitals right over here, right? So the lateral overlap of p orbitals is the double bond. So whenever these carbons are bonded to each other via a double bond, it means that there's a p orbital connected to those two carbon atoms bonded via the double bond, right? But that's the special characteristic of the double bond because the hybridization is sp2, which leaves a pure orbital or unhybridized orbital on that carbon atom because of the presence of that hybridization, right? And we don't see this bonding characteristic in an sp3 molecule, and that's obviously because all of the orbitals in an sp3 hybridized atom, they're all hybridized. There is no room for pure p orbital or unhybridized p orbital, okay? So now whenever we see the double bond, we know that they have pure p orbitals sitting on them. And now if we see these pure p orbitals like connected to each other, so they're in continuation, there is no gap. They're literally p orbital, p orbital, p orbital, p orbital connected to each other. That scenario is what we call conjugation in chemistry. Kind of makes sense, right? Conjugation in connection with each other. And in chemistry, we use that terminology for p orbitals. So now we're going to say, okay, that compound is a conjugated compound. All right, so in other words, every time you will see an alternating double single bond, right? So if you see an alternate double bond alternated with the single bond, double, single, you would call that compound as a conjugated compound. So you don't have to like really think about orbitals. Sure, you have to have an understanding of the orbitals, but if you just see an alternating double single environment in that compound, you would call it a conjugated compound, right? Okay, so that's just totally, all right. And now let's think about what happens when there is a positive charge, right? Okay. Before we do that, let's go back to the previous molecule really quick and think about the orbitals one more time. So again, this carbon has the p orbital, this carbon has a p orbital. They are in conjugation. This is in conjugation. They're in connected, right? And this structure, this orbital diagram does not include this, this bond and this bond, and it's supposed to be there, but it's not there, just for the purpose of explanation of using these p orbitals. Okay, all right. So now we call this molecule as a conjugated molecule, and actually the implication of these conjugated molecule is that the resonance structures are present because of the presence of the conjugation. And the reason for that is that these electrons we see, right, there's one electron here, they're forming the bond. They can just hop around in the next orbital because you see another orbital lined up, and that's also perpendicular. So electron can just hop on to the next one, hop on to the next one, right? And because of which we get other resonance structures, because how the movement of electrons is possible in this conjugation or in this conjugated type of structures. So resonance is then an implication of the conjugated molecules or conjugation present in the molecule, right? All right, so the first structure is conjugated, or we can say that this part of the first structure is under conjugation or is in conjugation. Okay, let's think about the second one now, right? So what we see in the second molecule is actually that the first carbon, the first two are double bonds, right? And we see that there are obviously then p orbitals on the first two carbons. The third carbon is a positive charge, right? And if that's a positive charge, so let's go back to hybridization again. Positive charge is nothing but an empty p orbital, right? Any time you see a positive charge on a carbon, especially, that would be an empty p orbital. CH2 positive is a p orbital. So that's also, it doesn't matter if it doesn't have any electron in them. It's still a p orbital in conjugation. And that's what chemistry terminology mean, that these orbitals should be in conjugation. It doesn't matter whether they have electrons in them or not, right? So then again, then we have that double bond in conjugation with that positive charge. So now, is this molecule in conjugation, or is the entire molecule in conjugation? Yes, it is. You wouldn't say that only this part of the molecule is conjugated, or never mind, I said that. So you wouldn't say that this molecule is isolated or there is no conjugation because this is a positive charge, but actually that positive charge is providing that p orbital for these electrons to hop around, move around, and that's why this entire molecule is in conjugation. All right, let's look at the third molecule, which is this molecule right over here. So in this third molecule, what we see is that this carbon atom connected to this carbon atom, again, they are sp2 hybridized because it's a double bond, so it has pure p orbitals sitting on them. So these are the pure p orbitals, which can lead to conjugation. And for the third one now, what we see is that the next carbon atom has no double bond, no positive charge present on it. And it's only sp3, it's not sp2. So that carbon right over here is sp3 hybridized, right? So what's important to learn conjugation is hybridization as well. So it's important to know hybridizations when we're learning conjugation. So if that's sp3 hybridized, and we know that for an sp3 hybridized carbon atom, there's nothing like a perpendicular p orbital. We don't, sp3 hybridized carbons don't have perpendicular p orbitals, which then breaks the continuation or connectivity of those p orbitals, because now there is a break here, right? And now they're not like all connected to each other, and that's why then this compound is not in conjugation with, or this compound is just not undergoing conjugation. All right, let's go to the next problem. Again, this is a pretty much an extrapolation of what we saw in the second problem, right? So we see again p orbitals. We see a p orbital, right? P orbital, they are in conjugation, and then there's a positive charge, which is nothing but an empty p orbital, and then again more conjugation. So now all of these are in line with each other. So we say that yes, the entire molecule is undergoing conjugation or is in conjugation, or it's a conjugated molecule. All right, let's look at the next one. And now what we see in the next problem is slightly different, right? What we see over here is that there is a negative charge Let's go back to hybridization, right? A negative charge is nothing, again, but a CH2 negative charge, a p orbital, there is a p orbital there, but there are electrons sitting in them. So if there is an electron pair sitting in the p orbital, that's okay, it doesn't matter. That's not what the definition says, that it doesn't matter whether your orbital have electrons in them or it doesn't have electrons in them. If it's still in conjugation, if it's still in connectivity, if it's still connecting those other p orbitals, that's totally fine. So there's a negative charge, which is nothing but p orbital having electrons in it, again connected to the carbon, which is double bonded to another carbon, meaning again there are p orbitals present, and then connected to another double bond, so another p orbital is present, connected to a positive charge, again an empty p orbital. So the entire chain has then p orbitals. Again, notice here that I have not drawn out this bond here, which is this bond, again not drawn out this bond, right? But they are there. They've just been eliminated for the purpose of explanation using these orbitals, but they exist, okay? All right, so now we see that, again, this is also a fully conjugated molecule. All right, and all right, so before we conclude for this video, I just wanted to mention that the lone pairs present on nitrogen are also present on the lone pair or present on the p orbital of that nitrogen. So that also can be responsible for conjugation in the molecule, right? The negative charge present on oxygen is sitting in the p orbital of that oxygen, or the lone pair sitting on that oxygen is also sitting on the p orbitals of that oxygen atom. So they are also responsible for conjugation. So they can also lead to conjugation, and as a result can lead to resonance structures in the molecule. So if you see those compounds as well, you would also include them as conjugated molecules. Pretty much, yes. Okay, and that's it for today. And then we will look at aromaticity going forward in the next video. I will see you guys in the next video.